Alright, as you can see, it's already started here. I had to restart it because I had to go get a calculator. So here, I said that it was a negative correlation because as you draw a line between the dots, right? You notice that all the dots are leading down, right? So that means from left to right. That's always how you read a graph. From left to right is going what? Down, right? So it has a negative what? Correlation. If it was going up this way, positive, like going in that way, right? Then it would be what? Positive. If it has no correlation, that means the dots will be all over the place, right? That would be no correlation. Non-linear correlation, that means that they probably form some kind of shape. Maybe you can have a circle or something, but it's not a straight, it doesn't form a straight line. See how these points are all like in this area? That forms a line. Alright, so that'll be negative correlation. Okay, so it says, what is the vertex of the graph of a quadratic function, right? So here we're going to use a calculator, right? So we're going to type in y equals, right, x squared, right? See the square button right there? And then we're going to say plus 6x. Oops, press the wrong one. It's okay, everybody makes mistakes. So you probably see that x right there? And then what else? Plus a 10. So it should look like that. Push graph, right? As you notice, it's 3 to the left. 1, 2. Let me zoom it in. See right there? It's 3 to the left. 1, 2, 3. And then 1 what? 1 up. So I'm going to draw 3 dashes. 1, 2, 3. Kind of off a little bit, but 1 up. But as you see in the video, right? It's 1, 2, 3. Right? 3 to the left and 1 up. Right? In order to read the vertices, right? That's the vertices right there, right? The tip of the parabola. The minimum, it's a min, right? So the vertices, vertex, right? You would read it on the x. It goes negative to the left, right? So it's negative 1, negative 2, negative 3. So that'll be negative 3. And then we go up how many, y'all? 1. So it'll be negative 3 and up 1. So that'll be h. Right? Alright, let's go to the next one. Alright. So here it says, which of the following graph represents a system of equation that has no solution? No solution, right? No solution is the key term that we want to look at. No solution, right, means that the two lines never intersect. That means that the two lines are both what? Correct, parallel. I'm not a good speller, so if I spell it wrong, I'm sorry. Parallel, right? So y is equivalent to mx plus b. That means that this part, the slope on both of them are the same. Same, right? That's what parallel means. They get the same slope. So they never touch. Okay, so which of the following graphs best represents a system of equation that has no solution? Here, this right here intersect at one point, right? So when two lines intersect at one point, so this is a line, this is a line. That means it's a what? One what? Solution. Right? Now if you got, now here, these two lines, you can say they don't touch, right? But if they were to extend, if you were to extend them, they meet up here, right? So they do touch. What about these lines? If you were to extend these lines, right? In a matter of time, they're going to what? Sooner or later, they're going to what? Intersect. So that's why the only two that don't intersect would be D. right? That's when they're parallel. Okay, now let's go on to number 4. Okay, we're at 5 minutes. All right, number 5, or no, we're going to do number 4. Okay, here it says a family will travel 350 miles from their house in order to reach Dallas, Texas. Which inequality can be used to find all possible values of t, the time it will take his family to reach Dallas in hours if they travel at an average speed of at least r miles per hour. That means that for every hour they travel so many miles, and they're going to give it to us, right? So sometimes you want to think of a real world example. Like this is Dallas, Texas, kind of like where we're in, right? We're in, but we're really in Duncanville. So we'll think. Let's make up an example for us. Say we have 400 what miles, right? And then per hour, usually on the highway, if you take the highway, that's usually what, 60 miles an hour, right? So we would divide that by what, 60, to find out how many what hours you need. How many hours you need, right? Your total miles divided by 60 miles an hour for every hour, we're going to find out how much hour it took us, right? So as you notice, the total always goes on the what, y'all? Correct, on the top. The total miles always goes on the top, right? So here we have a total of 350. So the only place it's on top is on H, okay? And just because I've done so many problems for this test and analyzed so many problems, the only time you use r squared or anything squared, it's when they tell you that they use quadratic. When they say in here, it says quadratic, right? And then you have to use it. Otherwise, you don't, right? Or sometimes they say in this question, they'll say x squared plus 2x. They'll use it in the question. They're not going to have it in the answer choice most of the time, okay? All right, here we have t is less than or equal to 350, right? If they want to know how many hours, 350 hours is a long time, y'all, right? So there's no way that it's going to, if we say, if we put 1 in for r, it's going to be 350. So if we put 2 in, it's going to be what? 700. So there's no way that f makes sense, right? There's too many. So it's either going to be g or h, and basically the total always goes on the top, and the total is what? 350, or like a big number always goes on top, right? So that would be h. And also if you were to find out if you have how many miles and how many miles per hour, we would say 400 divided by what? 60, right? So now let's attempt number 5. Let me see how much time. All right, I'm going to try one more and then I'm going to go to the next video. All right, the graph below shows a relationship between the numbers of dollars. Let me zoom it in some so y'all won't see my pants. Nah. All right, so the graph below shows a relationship between the number of dollars a worker earns and the number of hours worked. Okay, if you pay attention to this, y'all, the first thing you have to look at when you have a graph is analyze the graph. It's talking about money earned. A lot of us can relate to that. We're in high school already, right? And over here is the money earned. Cash money, right? Over here is what? Time. Okay, when you talk about slope, a lot of y'all have heard of rise over run, right? Some of y'all have heard of delta y over delta x. A lot of y'all have heard, I'm pretty sure y'all have heard of this formula, y2 minus y1 over x2 minus x1, right? What do y'all notice? What's on top, y'all, when you compare when you're comparing the slope, or when you're trying to figure out how to describe the slope? The what? Correct, the y. The y is on top and the x is at the bottom. What is here, y'all? What is y here? Let me drink some drink real quick. What's at the top, y'all? It's money, right? Your y? It's money. So we're going to put money on top per. The division sign means per each, for every, It can mean any of those things. Per, each. That's when you hear that terminology, most likely they're talking about the slope. So the X represents what, y'all? Hours. So it's dollar per hour. So look at the answer choices. The first one talks about the number of hours worked to get 320. It's talking about an exact value. But they want to know the overall, what does the slope mean in general, right? So we don't want to know exactly about a value. Here's another one. C is talking about 40 hours. We don't want to know exactly about a value, right? We want to know in general what it means. And if here it says money per hour, look, here goes the word right here. It could have said each hour. It could have said every hour, 4 hour. You know, all that means is this division sign. Okay? So money per hour has to be B, because here it says hours per dollar. It's backwards, right? Money earned Y per X. Y over X. So there's going to be B. And then I'm going to conclude this video. And I'm going to get started on the next one.